Hey guys, today I'm going to solve a problem using Gauss law. In this question we have a point charge q that is located on the axis of a disk at a distance b, and the radius of the disk is big R. I have drawn this diagram right here, figure 1, and the question also says that if 1/4 of the electric flux, 1/4 of the total electric flux from the charge passes through the disk, prove that the big R is equal to radical 3 times the distance between the charge and the disk, that is B. Okay, as I said earlier, we're going to use the Gauss law in this question. So by Gauss law, total flux produced by this charge is q over epsilon naught, but the question says that only 1/4 of this flux passes through the disk, that is the flux that passes through the disk would be q over 4 epsilon naught. So now we need to calculate the flux through the disk, which is given by this formula right here. Flux of the disk is integral of electric field times dA, and this should be equal to q over 4 pi epsilon naught as stated in the question. So in order to find the flux, I made this disk into annular ring as in figure 2 shown right here. Both of these figures are not drawn to scale. My circle aren't that quite a circle, but what I've assumed here is dA is the area of the annular ring with the radius small s and width ds right here, and electric field at the ring make an angle theta with the normal to the ring right here. This dotted line is the normal and electric field is going in this direction, which makes an angle theta. So now the flux through the ring, which I say is d phi ring, is equal to electric field times dA. The area makes an, so we have angle theta, so it is E dA theta. Now the area is 2 pi r, r is s times ds, so E times 2 pi s ds cosine theta. And the magnitude of electric field has the same value at all points on this annular ring. So we have electric field on the ring is 1/4 pi epsilon naught q over r square. R is this distance right here. I have enlarged this right angle triangle right here. You can see the base is b and the perpendicular is s. By Pythagoras theorem, r square is s square plus b square, so we have 1/4 pi epsilon naught times q over s square plus b square. Also using the same right angle triangle, we have cos theta is equal to b over r, that is b over under root s square plus b square. So now plug in the value of cos theta and E in this equation right here. The flux becomes d phi ring is equal to qb over 2 epsilon naught s over s square plus b square to the 3/2 power times ds. Now we need to solve that integral first. So to get the flux through the entire disk, we need to integrate the flux we got here from s equal to 0 to s equal to r, that is over total distance r. So now the flux of the disk from 0 to r is d flux of the ring, so q over b 2 epsilon naught integral from 0 to r s over s square plus b square. I just plugged in value from previous equations. So for integration we assume x is equal to s square plus b square, dx is 2s ds. For we need to change the limit as whenever s equals 0, x equals b square, s equals r, x equals r square plus b square. So the electric flux of the disk is, I just plug in every value, the substitution method. I plug in all the value in the integral. When I solve this one, I got electric flux of the disk is q over 2 epsilon naught times 1 minus b over under root r square, capital R square plus b square. So this is the total electric flux through the ring. From the question it says only 1/4 of the flux passes through the disk. So we need to equate this one with q over 4 times epsilon naught, which gives 4b square equals r square plus b square, and hence r equals radical 3 times b proved. Thank you.